thought it'd be good to look back at this Pride Points set of problems and look at how students approach them. This first problem is a calorimetry problem with the roles kind of reversed. Instead of a cool bath into which a hot object is placed, it's a warm bath into which a cool object is placed. And the students do actually very well on this, except for one problem. The one number that the students kind of get hung up on is the initial temperature of the brass. It's measured down here on this graph, and they would maybe about half the time fail to realize that this distance here is about 10 degrees, and so the initial temperature of the brass is probably somewhere around 28 or so, but sometimes students misread that the zero in the corner as a zero for the temperature scale, and not realize that they were, the temperature scale was starting up somewhere above 25 degrees. The second problem is an interesting problem that asks students to place the middle charge somewhere, Q2, somewhere in between Q1 and Q3, such that the forces acting on Q2 cancel. Actually, it says that the net force on the middle charge is 0, and so recognizing that there's some point here, some value of x that will lead to the force from Q1 exactly canceling the force from Q3. It wasn't unusual for students to set up the problem correctly, but then a variety of algebraic problems could creep in. And one solution that I showed them when I returned to the classroom was simply setting it up algebraically and seeing how many things actually wind up canceling, including the value of Q2 and the constant in Coulomb's law. These numbers go away and make the remaining numbers a lot easier to manage and to kind of work their way through. On the upside, virtually every team recognized that if the distance from Q1 to Q2 is x, then the distance from Q2 to Q3 must be 1 minus x, which is a reasonable recognition to make, and that was made by essentially every team.